Hey there, welcome back to Adam Academy. I'm Arifa. Come on, let's continue the exercise here. We have got two lines, okay? Now these two lines we are going to compare by using these ratios. A1 by A2, B1 by B2 and C1 by C2. We are going to compare this and find out whether these linear equations are intersecting, parallel or coincident. Come on, let's get started here. Now, we'll compare with the ratios now. We know A1 will be 5, B1 is -4, C1 equal to 8. We'll just write the constants, okay? A2 equal to 7, B2 equal to 6 and C2 will be -9. Now we'll compare it now. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now A1 upon A2, that is 5 upon 7, -4 upon 6, 8 upon -9. Okay, so can we cancel this? Not possible. Okay, this will go in two table. 2 2s are 2 3s are. Okay, this will not get cancelled. Now as you can observe, 5 upon 7 is not equal to -2 upon 3. Is it equal? No, it's not equal. So we say that this pair of linear equations have a unique solutions and they are intersecting lines. I hope this is clear to you all students. Come on, let's solve next question here. Now we have got again the pair of linear equations and we'll compare with the ratios. Now first A1 equal to 9, B1 will be 3, C1 equal to 12, A2 equal to 18, B2 equal to 6 and C2 will be 24. Now let's compare. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Okay, A1 upon A2 will be 9 upon 18 equal to 3 upon 6 equal to 12 upon 24. Now will this get cancelled? We'll just check. 9 ones are 9 twos are. 3 ones are 3 twos are. 12 ones are 12 twos are. So on the whole, I got here 1 upon 2 equal to 1 upon 2 equal to 1 upon 2. Now all these are equal to each other. Now we say that pair of linear equations have infinite solutions. Infinite solutions as they are coincident. I hope this is clear to you all students. Come on. Here we have got two linear equations and we have to compare these linear equations and find out whether they are intersecting, parallel or coincident. Come on, let's get started here. Now first one we have got A1 equal to 6, B1 equal to -3, C1 is 10. Now second linear equation, A2 equal to 2, B1 equal to, see we don't, B2. So here you can observe that we don't have any number. That means it is 1. Okay, as it is negative, we say -1. Now C2 will be 9. Now let's compare here. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now here A1 upon A2 is 6 upon 2. B1 upon B2 is -3 upon -1. Here 10 upon 9. Okay. 2 ones are 2 3s are. Minus gets cancelled. Here this will not get cancelled. So 3 upon 1 equal to 3 upon 1 equal to 10 upon 9. Are these, see these two are equal, but this is not equal, right? So it is not equal. I can say that they have no solutions. The pair of linear equations have no solutions as they are parallel to each other. I hope it is clear to you all, right students? You can see we have got a pair of linear equations, right? Pair of linear equations, and we are going to compare these linear equations, and we have to find out whether it is consistent or inconsistent. Consistent means at least it should have one solution. Now this is a graph, students. Okay, I'll just draw 3 graphs. These 2 lines are intersecting at one point. Okay, so this is intersecting lines. At least we have got one solution. This is a parallel line. We don't have any solutions here. Now this one, you can see that the lines exist in the same location on the graph. That means 2 lines line up exactly with each other and the points are the same. Okay, here we have got infinite number of solutions. Here we have got at least one solution. We have got here unique solutions we have got, but here we don't have any solution at all. This is intersecting lines. We call this as consistent. Okay, consistent. And this also it is consistent. Okay, here we have got infinite number of solutions. Here we have got unique solution. At least we have got solutions, but here we don't have solution at all. So we call this as inconsistent. I hope this is clear to you all. A1 equal to 3, B1 equal to 2, C1 equal to 5. Here we have got A2 equal to 2, B2 equal to -3 and C2 equal to 7. Let's compare. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now A1 upon A2, that is 3 upon 2, 2 upon -3, 5 upon 7. Can you observe? Are these equal to each other? No way. They are not equal to each other. So it is intersecting lines. The pair of linear equations are intersecting, and we say that it is consistent, student. Consistent. I hope this is clear to you all. Right, students? We have got a pair of linear equations. Let's compare and find out whether it is consistent or inconsistent. Now first one is, we'll just write here A1 equal to 2, B1 equal to -3 and C1 equal to 8. Now similarly A2 equal to 4, B2 equal to -6, C2 equal to 9. Okay, now we'll compare. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now A1 upon A2 is 2 upon 4, B1 upon B2 is -3 upon -6, C1 upon C2 is 8 upon 9. Okay, now 2 ones are 2 twos are, 3 ones are 3 twos are, and signs gets cancelled. I'm going to get half equal to half, okay, is not equal to 8 upon 9. Are these both equal? Of course not. They are not equal. So if these are not equal, we say that they are parallel lines. Parallel lines, no solution, right? So we say that it is inconsistent. Inconsistent. I hope this is clear to you all, students. Now this will be A1 equal to 3 upon 2, B1 equal to 5 upon 3, and C1 will be 7. Here A2 equal to 9, B2 equal to -10, C2 equal to 14. Come on, let's compare. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Okay, A1 upon A2, 3 upon 2. Okay, so this is 3 upon 2 upon 9. If we write, this 2 will go in the denominator, and we just write 3 divided by 2 into 9. Okay, now similarly I have got here 5 upon 3 whole divided by -10. So 3 will go in the denominator, so I'll get 5 upon -3 into 10. I hope this is clear. So 3 will go down, 3 into 10. Here I'll just write 3 upon 2 into 9, okay, equal to 5 upon 3 into minus 10 equal to 7 upon 14. Okay students. Now here 3 ones are 3 threes are, 5 ones are 5 twos are, 7 ones are 7 twos are. Now here we have got 1 upon 2 threes are 6. Okay. Now here we have got 1 upon minus 3 twos are 6. Here we have got 1 upon 2. Can you say that these both are equal? Are these equal? No, they are not equal. So we say that it is intersecting and it is consistent. Okay, because we have got intersecting has got one solution, that is unique solutions we have got. So it is consistent, student. It is intersecting and it is consistent. I hope this is clear. चलिए अभी नेक्स्ट क्वेश्चन सॉल्व करते हैं. Now here we'll just compare these linear equations and find out whether it is consistent or inconsistent. First, a1 will be 5, b1 equal to minus 3 and c1 equal to 11. Similarly, a2 equal to minus 10, b2 equal to 6 and c2 is minus 22. Let's compare. a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Now a1 upon a2, that is 5 upon minus 10, b1 upon b2 is minus 3 upon 6 and 11 upon minus 22. Okay, 5 ones are 5 twos are. Okay, 3 ones are 3 twos are, 11 ones are 11 twos are. Now this can be written in stand form, that is 1 up minus 1 upon 2 equal to, this is minus 1 upon 2 equal to minus 1 upon 2. Are these equal? Yes, of course they are equal. So they are coincident. They are coincident and consistent as well, because we have got infinite number of solutions, students. Okay. Now here we'll just compare. Okay, a1 equal to 4 upon 3, b1 equal to 2 and c1 equal to 8. Now here a2 equal to 2, b2 equal to 3 and c2 equal to 12. Now let's compare, students. Now we have got a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. This is very easy, students. Now 4 upon 3 into 2. As I said you, 4 upon 3 whole divided by 2. So this 3 will go in the denominator. 4 upon 3 into 2. Okay. Equal to b1 upon b2 is 2 upon 3. c1 upon c2 is 8 upon 12. Okay, 2 ones are 2 twos are. Can we cancel anything here? 4 twos are 4 threes are. Now I can write 2 upon 3 equal to 2 upon 3 equal to 2 upon 3. Okay, so all these are equal to each other. So we say it is coincident and consistent. I hope this is clear to you all, students, right? Here we have got a pair of linear equations and we have to check whether it is consistent or inconsistent. If it is consistent, we have to obtain the solutions graphically. Now come on, let's get started here. Let's check whether it is consistent or inconsistent. Okay, now here I'll just write a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So 1 upon 2, we'll just take constant numbers. Okay, here 1 and here 2. 1 upon 2 equal to 5 upon 10. Okay, now 5 ones are 5 twos are. I'm going to get 1 upon 2 equal to 1 upon 2 equal to 1 upon 2. It is coincident. Coincident mean it is consistent. Okay, it is coincident coincident, and it is consistent as well. Okay, now it's already a consistent, we know. If it is consistent, we need to obtain the solution graphically. Now first equation, equation 1, it is x plus y equal to 5. Okay, now y equal to 5 minus x. Let's get the solutions. Okay, this is a solution table for the first equation. Okay, now this is x, y. Okay, now if x equal to 0, y equal to 5 minus 0, which is equal to 5. If x equal to 1, so this is the main equation. We'll just put the values of x in this equation. Okay, now y equal to 5 minus x value is 1, which is equal to 4. Now x equal to 2, so y equal to 5 minus 2 equal to 3. Okay, so we have taken the values as 0, 1, 2, and I got the answer as 5, 4, 3. Okay, so this is from equation 1. So equation 2. Okay, equation 2. So equation 2 I have got here 2x plus 2y equal to 10. This numbers, that is 2 to 10, will get divisible by 2 table, right? So if I am going to divide this with 2, I am going to get x. Here 2 gets cancelled, I am going to get y. 2 1s are 2 5s are, right? So this is same as equation 1, students. Can you observe this? Yes. So I am going to get the same solution table. Okay, if I am going to give the values as 0, 1, 2, okay, I'm going to get 5, 4, 3. Come on, let's draw the graph, or let's plot the points on the graph, students. Now here we go. This is a graph sheet. Okay, so I have already drawn x and y axis. Now we'll just plot the points on the graph, students. 0, 5. Okay, 0 and 5 is on y axis. See, y axis. 1, 4. 1 is on x axis and 4 is on y axis. Okay, now 2, 3. 2 is on x axis and 3 is on y axis. Okay, let's draw the line. I hope this is clear to you all. So this is for the equation 1, this is a straight line, and for equation 2 also I'm going to get the same straight line. So this is coincident. Okay, I hope this is clear to you all, students. And here we have got again a pair of linear equations, and we have to check whether it is consistent or inconsistent. If it is consistent, we need to obtain the solutions graphically. Now here you can observe, okay, A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now A1 has got 1. Okay, this coefficient is 1 here. Here we have got 3. B has got -1, and here we have got -3. Okay, C has got 8 and C2 is 16. Okay, C1 is 8 and C2 is 16. Now the sign gets cancelled here. Here you can see 8 1s are 8 2s are 16. It is 1 upon 3 equal to 1 upon 3 equal to 1 upon 2. Are these two equal? They are not equal, right? So this is parallel and inconsistent, student. Okay, it's parallel and inconsistent. When it is consistent only we can obtain the solution. When it is inconsistent, we'll just leave as it is. Okay, I hope this is clear. Now we can compare this linear equations. Okay, pair of linear equations. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now A1 upon A2 is 2 upon 4 equal to 1 upon -2. Okay, so you can even write this 6 to the other side. You're going to get +6. Okay, here if you're going to shift this 4 to the other side, you're going to get +4. No issues, you can just write minus 6 upon minus 4. Okay, 2 ones are 2 twos are. Here signs gets cancelled, and here it is 2 threes are 2 twos are. Okay students, now here it is 1 upon 2 equal to minus 1 upon 2 equal to 3 upon 2. As these both are not equal, so these both are not equal means it is intersecting and it is consistent. Okay, now as this is consistent, we need to obtain the solution graphically. Now we'll take equation 1. So here we have got 2x plus y minus 6 equal to 0. Okay, y equal to, shift this to the other side, you're going to get plus 6 and this will become minus 2x. Okay, now we'll give the values for x equal to 0, x equal to 1 and 2. Okay, here it is y equal to 6 minus 2 into 0. The whole thing will get 0, you're going to get only 6. 2 zeros are 0, 6 minus 0 will be 6. X equal to 1, y equal to 6 minus 2 ones are 2. Now this is 2. 6 minus 2 is 4. Right. Now x equal to 2. So y equal to 6 minus 2 into 2. Here 2 twos are 4. 6 minus 4 equal to 2. Now let me draw the solution table here. Okay. This is a solution table. X, y. All the x values are 0, 1, 2. And here we have got 6, 4 and 2. I got a solution table. Let me go with equation 2 students. Okay. Now here I have got 4x minus 2y minus 4 equal to 0. As all this will get divisible by 2 students here. Now 2 twos are 4. Okay, 2 ones are 2 and 2 twos are 4 equal to 0. Okay, as this is negative, only this I am going to shift to the other side. I am going to get 2x minus 2 equal to plus y. I hope this is clear. See, we have got here negative y. If it is negative y, you can directly shift to the other side students. Okay, so finally I am going to get y equal to 2x minus 2. This is a main equation I got here. Now let's start giving the values for x. X equal to 0. Y equal to 2 into 0 minus 2 equal to, the whole set will get cancelled. I am going to get minus 2. X equal to 1. Here y equal to 2 into 1 minus 2. 2 ones are 2. 2 minus 2 is 0. X equal to 2. Here y equal to 2 into 2 minus 2. 2 twos are 4. 4 minus 2 is 2 students. Now this is a solution table. Okay, this is a solution table. This is xy. I got the values here 0, 1, 2 and here I got minus 2, 0, 2. Okay, so this is what the solution table I got for equation 2 and this is for equation 1. Now let's plot the points on the graph students. Now first solution, okay, solution table will follow. 0, 6, 0, 6. 0 is here and 6 is on y-axis. I got the point here. Okay. 1, 4. 1 is here, 4 is on y-axis. Okay. 2, 2. So 2 is on x-axis and 2 is on y-axis. Okay, let me draw the straight line. Now we'll go with second solution table. Okay, second solution table. Here we have got 0, minus 2. 0 is on x-axis and minus 2 is on y-axis. Here we get minus 2. Now 1, 1, 0. 1 is on x-axis and 0 is on y-axis. So we get a point here. Okay. 2, 2. 2 is on x-axis and 2 is on y-axis. This is what I got the point. Now we'll join all the 3 points students. Now you can observe students, these are intersecting lines. Intersecting and consistent I said you. So these are intersecting lines, I got it. I hope this is clear to you all. If you have any doubt, please leave your comments in the comments box, students. Let's compare it. Okay, now here we have got a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Come on, a1 is 2 and a2 is 4. b1 is minus 2 and b2 is minus 4. c1 is minus 2 and c2 is minus 5. Now here 2 ones are 2 twos are, okay, minus minus gets cancelled, 2 ones are 2 twos are, minus minus gets cancelled. Okay, now here we have got 1 upon 2 equal to 1 upon 2 equal to 2 upon 5. Are these both equal? No, they are not equal, right? So this is parallel and inconsistent, students. Parallel and inconsistent. Okay, if it is consistent, we would have gone graphically. Okay, as it is inconsistent, so we are not drawing the graph, students. I hope this is clear. Here we have got half the perimeter of rectangular garden. This is a rectangular garden whose length is 4 meters more than its width. So we'll assume that let width be x and length be y. What is perimeter? Perimeter means sum of all the sides. Sum of all the sides. We know the formula: perimeter equal to twice of L plus B. Twice of L plus B. Now half the perimeter means if I am going to do half into 2, the whole set I am going to write like this: L plus B. Okay, 2 gets cancelled. I am going to get only L plus B. Okay, that is perimeter equal to L plus B only when it is half the perimeter. Okay, so now whose length is 4 meters more than its width? Whose length is equal to 4 more than its width. So this is width, which is 4 more than its width. Okay, I got this equation 1, or else further you can write this as y minus x equal to 4. Okay, students, this is first equation we got. And the half of the perimeter is 36 meters. 36 meters. Now I can write this as, okay, I'm going to write here as y plus x equal to 36. Width plus length equal to 36. This is equation 2. Is this clear, students? यहाँ पे देखिए, मैं क्लियर करती हूँ. हाफ द पेरीमीटर, पेरीमीटर का हाफ कितना है? हमको सिर्फ L प्लस बी मिला है, जिसका लेंथ है, लेंथ इज 4 मोर देन इट्स विड्थ. विड्थ से मतलब लेंथ का जितना है, लेंथ वी हैव रिटन एज y. y इक्वल टू 4 मोर, मतलब विड्थ से ज़्यादा है, 4 मोर, 4 मीटर्स ज़्यादा है. सो आई कैन से x प्लस 4. ठीक है, सो लेट मी राइट इन द इक्वेशन फॉर्म. इसको स्टैंड फॉर्म में लिख दीजिए. y x को इस तरफ लेके आ जाइए. y माइनस एक्स इक्वल टू 4. दिस इक्वेशन 1 बन गया. इज 36 मीटर. किसका है 36 मीटर? हाफ द पेरीमीटर का वैल्यू है 36 मीटर. ओके, रिटर्न. Find the dimensions of the garden. So we need to find out the dimensions, students. To find out the dimensions, हम क्या करेंगे? Values डालते जाएंगे. X का value. Okay. Now let me consider this equation. Y equal to x plus 4. Okay. Equation 1 ले लेंगे. Okay. Equation 1. इसी से तो ये आया है ना? So I can consider this equation. तो यहाँ पे x equal to 0 डाल देंगे. y इक्वल टू 0 प्लस 4, तो मुझे मिला है 4. ओके, x इक्वल टू 1 डाल देंगे. y इक्वल टू, सो दिस इज अ मेन इक्वेशन. ओके, अभी यहाँ पे 1 डालेंगे. 1 प्लस 4 इक्वल टू 5. अभी x इक्वल टू 2 डालेंगे. y इक्वल टू 2 प्लस 4 इक्वल टू 6. राइट स्टूडेंट्स, तो मुझे 2 प्लस 4 इक्वल टू 6 मिला है. Now this is a solution table. सॉल्यूशन टेबल x y, x के वैल्यूज होंगे 0 1 2 एंड y का वैल्यू होगा 4 5 6। चलिए अभी इक्वेशन 2, जस्ट फॉलो इक्वेशन 2 नाउ। तो यहाँ पे y प्लस x इक्वल टू 36 है, तो y इक्वल टू 36, x को उस तरफ लेके जाएंगे, आई गॉट 36 माइनस x। तो चलिए अब हम x के वैल्यूज डालते जाएंगे विच शुड बी क्लोजर टू 36 के नज़दीक आने दो इसको। आई टेक x इक्वल टू 30 डाल देंगे, x इक्वल टू 30 डालेंगे तो y इक्वल टू 36 माइनस 30 इक्वल टू 6। ठीक है, अभी x इक्वल टू 31 डालेंगे, y इक्वल टू 36 माइनस 31 तो हमको मिलेगा 5। x इक्वल टू 32 डालेंगे, y इक्वल टू 36 माइनस 32, I got 4. Okay, so this is the solution table. Okay students, this is x y. अभी x के वैल्यूज यहाँ पे डालेंगे 30 31 32 and my answer is 6 5 4. Okay students, now this is a graph sheet. Okay, you can observe here that x-axis I have taken 5 centimeter equal to 1 unit. I have written here. This is a scale. This is very important to maintain. And in x-axis 2 centimeter equal to 1 unit I have written. Right? Now come on, let's plot here. I've got 0 4. 0 is on x-axis, 4 is on y-axis. Okay. Now next is 1 5. As you can see 2 2 division equal to 1. Okay, here 1 5 1 5 1 2 divisions, 1 and 5 is here. I got the point. Okay, 2 6, 2 means 4 divisions, 2 and 6 I got here. Okay, let me join all the points students. Now we'll go to second this one solution table. 30 and 6. 30 is on x-axis and 6 is on y-axis. I got the point here, 30 and 6. Okay, 31 and 5. 31 2 divisions and 5 is here. Okay, 32 and 4. 32 4. 32, that is 4 divisions, 32 and 4 I got here. Okay, let me join all the points and get the dimensions of the garden. Okay students, so I have joined all the points here on both the sides, 2 equations. Okay, now as you can see that from the graph you can see that lines intersect each other at the point. So this is 16 16 and 20, hence the width of the garden is 16 students and the length is 20. I hope this is clear. So we got that is width x equal to 16, okay, and y equal to 20. So this is what the width we got, okay, by plotting the points on the graph. Okay, I hope this is clear.